All right. Well, real quick, this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I'm the program manager here at the Green Home Institute. This session is approved for multiple continuing education units, as well as AIA, health, welfare, and safety, which may make it applicable to your state-based design or contractor license. Also, this session is approved for our certified green home professional designation. Got the wrong logo there. This is actually under energy and health if you're trying to pick those up. And because of the AIA approval, it may be applicable to your state-based design or contractor license. And before we get started, I always have to say a huge thanks to our board of directors, all of our speaking volunteers this year, our new executive director, Jose Arena, and our top tier sponsors, Mitsubishi Electric, April Air, Rheem, Build Equinox. They're all going to help you meet green building strategies, certifications, going all electric, net zero. They're all going to there. All of our sponsors are going to help you do that. And just today, I'm super excited to announce that we received our GuideStar Platinum certification for 2021. So check that out. All right. Well, I am super excited to hand it off to our speakers today. For those of you listening, I will be uploading the handout into the chat, and those of you on demand, you'll be able to access that from the download. So stay tuned for that in a second. But I'm going to hand it off to, first we have Rebecca Stam with us, and then we also have Vienna Singla. So I'm going to hand it off to you, and I'm super thankful for you joining us and the Healthy Building Network and NRDC. So please do take it away.
There we go. Well, good morning, good afternoon, good evening, depending on where you're calling in from. I saw participants from all over the globe. It was really, really wonderful to be here, and appreciate Brett and the Green Home Institute for hosting this webinar. My name is Vienna Singla. I'm a senior scientist with the Natural Resources Defense Council. I'm based in San Francisco, California. So our plan for today, I want to tell you a little bit about the Natural Resources Defense Council, or NRDC, and then talk a bit about the intersection between buildings, climate, energy efficiency, and our health. I'll give a bit of an overview about why we're concerned about toxic chemicals in building materials, and then I'll turn it over to Rebecca to talk about the Healthy Building Network and healthier choices for insulation and air sealing materials, and some of the resources available to help support these choices. But first, since we're going to be talking a lot about insulation today, I wanted to get a better sense for you all on the line of what kinds of materials you might be using, specifying, purchasing in your work. So if Brett, if you can pull up that poll, and please just go ahead and select which materials. And you can select more than one, I believe.
Looks like we're at about 50% participants, getting closer. 58%, 60. Got to think about it. What did I last use? I don't know. I don't remember. Just told the builder to throw in something that hit an R value of R15, right?
Yeah, no, that's a good point. Yeah.
Right,
thinking about the performance, right? Not the material.
Right. We're at 72%, probably a good turnaround if you want me to end it. Yeah.
That sounds good. All right, good. We're seeing folks, hopefully you can see those results, but if not, we've got a really good kind of distribution across most of the materials, not so much on cork, but lots of cellulose, fiberglass, mineral wool, XPS, EPS, spray polyurethane foam. Great, so it's like what everyone's at least familiar with most of these materials, so we'll definitely be talking a lot more about them. All right, so I'll tell you a little bit more about NRDC. We're an international nonprofit that employs scientists, lawyers, and policy experts to advocate for evidence-based policies to protect human health and the environment. And we have a staff of about 700 and offices across the United States, as well as in Beijing, China. And we work on a range of critical issues related to the environment, including climate change and energy. And I'm a scientist that works at the science policy intersection, really focused on healthier communities. I do research and analysis to bring the most current scientific principles and data to inform policies to protect and advance human health, especially focused on buildings and healthier buildings. So why buildings? I think I don't have to tell this audience probably that building operations are a large contributor to climate emissions when we're thinking about climate impacts. And this really connects to energy efficiency, both as a way to reduce climate emissions and also to cut down on energy bills. I saw in the chat there's someone serving low-income multifamily affordable housing. That's one of the places we see some of the highest energy burdens. So the really energy efficiency is really important there. And then finally, buildings can really affect our health for better or for worse. So thinking about health, I work on environmental health, and that's how the environment impacts our health. You know, there's these kind of three major intersecting pieces that that combine to influence our health. There's our genetics or genes that we're born with. There's our behaviors, the things that we do, like what do we eat? You know, do you smoke or drink, exercise? And then there's our environment. And the environment can have a really big and often kind of unappreciated impact on our health. So when we think about the environment, that's everything from the air that we breathe to the water that we drink, what's in our homes, what's in our neighborhoods. And what we've seen in terms of how the environment can impact health is some really concerning trends when we look at particularly vulnerable populations. In the last few decades, we see rising trends of certain diseases in children. For example, there's been a big jump in childhood cancer, asthma, as well as developmental disorders. And what we find is that studies reveal that environmental exposures can contribute significantly to increased risks for these kinds of chronic diseases. And when we talk about environmental exposures, what does that mean? That means contaminants that we can eat, breathe, drink, and absorb from food, water, products, and places. And today we're really thinking about places, right? Buildings, it's the place that we live, learn, work, and play. And thinking about some of the environmental exposures related to buildings, we can think about mold, moisture, pests and their associated allergens and chemicals, and volatile organic chemicals have all been linked to causing and exacerbating asthma. Chemicals found in buildings and building materials like asbestos, formaldehyde, and PFAS, per and polyfluoroalkylated substances, also known as Teflon or forever chemicals, have all been linked to various cancers. And then finally, chemicals like lead, flame retardant chemicals, and pesticides used in buildings have been linked to developmental disorders like attention problems and loss of cognitive capacity. So when people think of the environment, a lot of times you think about the outdoors, right? Being outside. But in developed countries like the US, we spend upwards of 90% of our time indoors, actually. So whether you're at home, at the office, at the gym, and transportation, a lot of the environment we experience is really our indoor environment. So the ideal indoor environment, we want to support our health, comfort, and well-being. And there's a lot of interconnected factors that contribute to a good and healthy indoor environment. So we think about ventilation, the noise level, the thermal comfort, what temperature is it? What does the building energy usage look like? Are there contaminants indoors, outdoors? What about the humidity and moisture within the building? The presence of unwanted pests and organisms like mold, insects, rodents, and finally, the occupants' activity patterns that can affect many of these different characteristics like smoking or cooking. So, like I said, these are kind of interrelated factors. They're not really separate. For example, if you open a window to increase ventilation, that can really affect the temperature inside. So these are all really important to indoor environmental quality, but today we're really going to be focusing on kind of energy usage and energy efficiency and the link to indoor contaminants. So when we look at indoor contaminants, what we see is there's very often higher levels of particular contaminants indoors compared to outdoors. That includes VOCs, formaldehyde, flame retardant chemicals, called phthalates that are used in a lot of plastic materials like PVC, vinyl chloride, and these PFAS, Teflon forever chemicals. So why is that? Why are we seeing higher levels indoors? And one of the reasons is that building materials and products are sources of these indoor contaminants and not just for VOCs. So you can kind of see in this diagram, the products and building materials can emit and shed these chemicals into air and indoor dust. And then that contaminated air and dust is the way that the chemicals can get into our bodies when we breathe them in or come in contact with that contaminated dust. So this is a concern for building occupants, but not just for building occupants, because these chemicals have impacts across their life cycle, from the production of the chemicals and building materials to when workers are installing and using them, to in the home, to demolition and disposal and ultimate end of life. So across the life cycle, hazardous chemicals used in building materials can affect workers who are handling them, as well as communities that might be in proximity to the production and manufacture of the chemicals and materials, as well as the disposal. So you might be wondering, how are these materials that are constructing our homes that we live with every day, how can they contain these harmful chemicals? And aren't there some regulations that might be ensuring that hazardous chemicals aren't used? And I'd say, unfortunately, the answer is not yet. So in the chemical world, their chemicals are kind of divided up how they're regulated by uses. So for food, drugs, and pesticides, the Food and Drug Administration and the Environmental Protection Agency, EPA, have authority over those. And then pretty much everything else falls under the Toxic Substances Control Act, or TSCA, which falls to EPA. What are these chemicals? Well, it's about currently 40,000 industrial, commercial, and consumer product chemicals. So those are chemicals in everything from building materials to toys to children's products, to dry cleaners, to chemicals used in factories and industrial processes. It just covers a really wide range of chemicals that are used in our everyday lives and products. And what we've seen is that we really do not have good evaluation of these chemicals, especially related to health hazards. 1976 was when the original TSCA was passed. And since that time, about 20,000 new chemicals have been introduced, and the vast majority of them do not have health hazard data available. TSCA has kind of widely been seen as a pretty weak law. So for example, EPA was not able to ban asbestos under TSCA, which everyone knows asbestos is a notorious cancer-causing material. So this really kind of illustrates how the law is not effectively looking at chemicals used in products and ensuring that they're safe. So here's another poll question for you. Take a guess. Since 1976, that's when the Toxic Substances Control Act was introduced, how many chemicals do you think EPA has been able to regulate or partially regulate? None, 9, 90, or 9,000?
Had a missing 0 there on one of them. Sorry about that. But either way, I think it's in the middle somewhere. Looks like we got about 73% on the poll. So,
all right, let's see what you thought. Okay, we've got most people, about half people thought 90, maybe 9,000. Well, the answer is actually 9. It's only 9 chemicals. So this really brings home the importance of thinking carefully about what goes into our buildings. And as we're thinking about that, we want to really look for those solutions that are going to address these multiple issues, right? That sit at that intersection of energy efficiency upgrades that are going to reduce climate emissions and energy bills for occupants while creating healthier buildings for building residents and for people that might be affected by building materials across the life cycle. So I wanted to leave you with one quick thought about what keeps me motivated in this work every day. And that's this idea that the California Environmental Health Tracking Program looked at these childhood diseases, asthma, cancer, and developmental disorders, and found that if we could get rid of toxic exposures linked to these diseases, we could entirely prevent 30% of childhood asthma, 15% of childhood cancers, and 10% of childhood developmental disorders. So, we can't change our genes, at least not yet, but we can change our environment, and these changes can make a real difference for people's health. So I'll turn it over to Rebecca now to talk more about safer insulation and sealant materials.
Thanks, Veena, for that great introduction to why this is such an important topic. Can you see my slides there?
Looks great.
Okay, thank you. So now that we have that background on some of the connections between energy, climate, and health, you may be asking what you can do in particular to reduce the chemical impacts of the building materials that you use. So to help answer that question, I'll go into some of the details of our research and recommendations for safer insulation and air sealing materials, as well as pointing you to some resources to support you in using safer materials. So first, just a little bit about Healthy Building Network, or HBN. We're a national nonprofit organization with over 20 years of experience conducting research, providing education, and advocating for policies around the use of safer materials. So our mission is to advance human and environmental health by moving the materials market toward improved chemical transparency, as well as inspiring product innovation that results in safer alternatives. Really, ultimately, the goal of our work is to change the way that products are made so that they're safer for all people. So for this project in particular, we focused on insulation and air sealing materials as important components of new construction, as well as many energy efficiency retrofits. Worldwide, we all know there are these increasing efforts to improve energy efficiency of existing buildings to help mitigate climate change impacts. And as Veena mentioned, these energy efficiency measures like insulation and air sealing have a myriad of benefits. But unfortunately, some of those materials contain chemicals of concern. And these chemicals contribute to adverse health impacts, both for building occupants and others throughout the life cycle of products. So as Veena also mentioned earlier, the life cycle of a product includes all of these different stages. And when hazardous chemicals are used, people in the environment can be impacted at each of these stages. So I just want to illustrate this by using the story of residential fiberglass bat insulation to show how a single material can have a range of impacts throughout the supply chain, as well as how market demand for safer materials can lead to positive change. So fiberglass bat insulation includes a binder material that holds those fibers together into the desired shape. For a long time, basically since the first fiberglass insulation was made in 1938, those binders were based on formaldehyde. And even though formaldehyde was identified as a likely carcinogen in 1981, its use in fiberglass insulation continued for decades. And it's important to point out that despite the fact that insulation is typically installed behind drywall or other barriers, formaldehyde from the insulation can still enter the living space and expose residents. In addition to those impacts on building occupants, workers along the supply chain and communities near production facilities can also be impacted when hazardous chemicals like formaldehyde are used. So this graph shows the reported formaldehyde releases from residential fiberglass insulation manufacturing facilities in the US and Canada over time. These factories released nearly 600,000 pounds of formaldehyde into the air in nearby communities in 2005. Since then, market pressure for healthier alternatives, including improved green building certifications, has driven all the residential fiberglass insulation manufacturers in the US and Canada to phase out those formaldehyde-based binders in favor of less hazardous alternatives. So this change reduced exposure to formaldehyde for both building occupants and those impacted throughout the supply chain. So this is a happy story, a good story of how you and others like you have worked to change the market and how we continue to do that. So we're no longer concerned about formaldehyde, in particular in residential fiberglass insulation. What are the current chemicals of highest concern to look out for in insulation materials? Based on HBN's research into the common content of hazards in insulation, we've identified still formaldehyde in some products, halogenated flame retardants, isocyanates, organotin compounds, and particular blowing agents as those chemicals of highest concern in this product category. So we just talked about the prior use of formaldehyde in residential fiberglass insulation, and while it's been phased out in those products, formaldehyde-based binders are still used to hold together some fibrous insulation products like mineral wool bats and boards, as well as higher density fiberglass boards and pipe insulation. And this is a concern because formaldehyde is a known carcinogen. Chemicals that are persistent bioaccumulative toxicants, or PBTs, are of particular concern because they don't break down readily from natural processes, and they accumulate in organisms, concentrating as they move up the food chain. These chemicals can and do get into our bodies, not only from products in our buildings, but through that air and dust, as Vina mentioned, but they can also get into water and food and stick around for a long time in the environment. So because of their ability to bioaccumulate and travel long distances in the environment, PBTs in particular are a very high concern to avoid. I mention that because halogenated flame retardants, a group of chemicals of concern in insulation, can be PBTs and or carcinogens. Now, while flame retardant chemicals might sound like a good thing, as they're meant to slow fires, in reality, they've not been found to improve fire safety in this application, and they raise significant health and environmental concerns. They might actually make fires more dangerous by releasing additional hazardous chemicals when they burn. Some of these flame retardants can also migrate out of insulation products over the product's life and are commonly found in indoor dust. And halogenated flame retardants are commonly used in foam insulation materials. Isocyanates are another chemical of high concern in insulation products as asthmagens. Contact with a small quantity, either through inhalation or skin contact, can cause a person to develop the disease of asthma. And isocyanates are part of the unreacted chemicals in spray foam insulation that then react on site to form the plastic material. Organotin compounds are a concern as reproductive toxicants, and these are additional additives that are used in some spray foam insulation. And finally, particular types of blowing agents called Hfcs and HFOs are also a concern. Over the years, the industry has cycled through many different iterations of blowing agents that have had high environmental impacts, from chlorofluorocarbons or CFCs to hydrochlorofluorocarbons, HCFCs, both of which are ozone depleters, to most recently hydrofluorocarbons or HFCs that have a high global warming potential. Now, HFCs are still prevalent in XPS and spray foam insulation, but some manufacturers have started to shift from HFC blowing agents to low global warming potential hydrofluoroolefins or HFOs. There are still many concerns about the ozone depleting and high global warming potential materials that are used to produce those HFO blowing agents, and that may be released into the environment during that process. So how do we at HBN translate this information about the common chemicals and those of highest concern into action? So we use a simplified green to red spectrum in order to rank materials based on that common chemical content and the associated hazards. And we call this a hazard spectrum. Products in the green categories are typically the best options from a material health perspective. And those at the bottom of the spectrum in red are to be avoided. And those in between are intermediate options from a health hazard perspective. So as a general rule, we encourage selecting product types that are in the yellow and green categories and working your way up using the best materials possible for your application. I did want to mention these spectrums are not inclusive of all the different types of products that do exist, and absence from the spectrum isn't any commentary on the healthfulness of a product. It just means it's not something that we've included yet. So this slide shows where those chemicals of highest concern are found in insulation materials along the hazardous spectrum. Formaldehyde-based binders are found in most mineral wool bats and boards, as well as fiberglass boards. Halogenated flame retardants are found in most plastic foam insulation, including polyisocyanurate, EPS, XPS, and spray foam insulation. Organotin compounds and isocyanates are found in spray foam insulation, and HFC and HFO blowing agents, as I mentioned, are used in extruded polystyrene and in some spray foam insulation. Now, there are some product types that do have better options that we break out to acknowledge those manufacturers who have innovated these new improved products from a material health perspective. For example, there are some halogen-free polyiso products that are available, which move them from a light red to a yellow ranking. And there are also some formaldehyde-free mineral wool bats, which move them from orange to light green. Now we understand that material health is not the only consideration when you're making material choices. Performance and cost are also important considerations. So for insulation, this often means looking at the R value. So different types of materials have different insulation performance and therefore different R values per inch of material. So when considering cost, it's important to consider cost for a given performance. In this case, the cost for a given R value of insulation. So this table shows the reported R values per inch for the different types of insulation materials, as well as the relative cost per R value. The top ranked insulation on the hazard spectrum, expanded cork, is free of hazardous content, but it's also expensive and may have limited availability. But some of the best product types from a health perspective are also the least expensive. Commonly used fiberglass and cellulose insulations are near the top of our ranking, and these products also have the lowest installed cost for a given R value. Because they're free of the chemicals of highest concern, we recommend using fiberglass and cellulose insulation whenever possible. And these products also allow for some flexibility in terms of application and performance because they come in a range of different forms like bat, blown, and spray applied. One thing I wanted to note on insulation performance is that while the R value per inch is higher for many foam products, the R value per dollar is not, with most of those foam insulation products being ranked at $3 per R value. So the hazard spectrum allows you to choose the best material possible from a hazard perspective that will meet your other material requirements. And the best materials to use may depend on the application. One example is for continuous insulation on a building's exterior. Not all types of insulation can be used for this application. And since expanded cork is expensive and may not be available everywhere, the next best options from a material health perspective would be halogen-free polyiso or mineral wool board insulation. These materials avoid the halogenated flame retardants, and while mineral wool boards commonly still contain formaldehyde-based binders, this is less of a concern in this particular application because it's outside of the weather barrier, but it does still have those life cycle concerns associated with the use of formaldehyde that I mentioned earlier. So overall, our recommendations for safer insulation are to prefer fiberglass, formaldehyde-free mineral wool, or cellulose insulation. If board insulation is required, look to use expanded cork, halogen-free polyiso, or rigid mineral wool. We recommend that you avoid foam insulation, whether board or spray applied, whenever you can, and to use mechanical installation methods such as fasteners in order to avoid introducing unnecessary adhesives. One last point I wanted to touch on insulation is with regard to embodied carbon. So many architects and others are starting to consider the carbon impacts of products that are going into buildings. And this may be another consideration that you want to keep in mind when you're making material choices. Often material health and embodied carbon can work hand in hand, and that is the case with insulation, where the best materials from a health perspective also perform better in terms of embodied carbon. So in this case, the cork, cellulose, and fiberglass are some of the best options from both a material health perspective and from an embodied carbon perspective. So now we'll shift gears a little bit to talk about sealants. And these are the chemicals of highest concern in sealants based on HBN's research. And several of these you will recognize as also chemicals of highest concern in insulation: halogenated flame retardants, isocyanates, and organotin compounds. Other chemicals of concern found in sealants include orthophthalates, commonly just called phthalates. And these chemicals can be developmental toxicants, and some have also been associated with asthma, as well as cyclosiloxanes, which are persistent bioaccumulative toxicants, or PBTs. So this slide shows the hazard spectrum for sealants and which types of products typically contain those chemicals of highest concern. So cyclosiloxanes are found in silicone sealants. organotin compounds and phthalates are commonly found in modified polymer or STPE sealants, as well as polyurethane sealants. 1-part spray foam sealants contain halogenated flame retardants, and isocyanates are found in both 1-part spray foam and polyurethane sealants. So translating that into our overall recommendations for safer sealants, we recommend that you prefer caulk-type sealants over spray foam sealants, to use foam sealing products that aren't reacted on site, like a foam sealant tape or a backer rod instead of a spray foam sealant. Also to avoid orthophthalates, and to prefer acrylic-based sealants with very low levels of volatile organic compounds. The final recommendation is to avoid products that are marketed as antimicrobial and claim or imply some sort of health benefit. These products have not been shown to have any benefit on human health, and they can actually have negative impacts on human health and the environment. Another general recommendation that we make across all product categories is to prefer products that disclose their contents through industry standard documentation. Why is this important? We truly believe that you have a right to know what's in the materials that are going into your buildings. So transparency about this information is the first step to understanding and ultimately avoiding hazardous impacts on building occupants, on workers, and on those fence line communities. There are 2 types of industry standard disclosures: health product declarations, or HPDs, and declare labels. HPD is the industry's collaborative user-designed open standard for disclosing a product's content and associated health hazards. They're a standard reporting format that's managed by the nonprofit member association, the HPD Collaborative. And this group includes manufacturers, architects, and other ecosystem partners who work together to develop and maintain this standard for reporting. HPDs provide information on the content of a product, as well as screening that content against dozens of governmental and non-governmental lists for associated health hazards. So this includes things like California's Prop 65, US EPA and National Institute of Health hazard lists, as well as many international organizations' lists of health hazards. Declare is a material declaration program from the International Living Future Institute, and declare labels disclose the product content and then indicate specifically whether products contain chemicals on the Living Building Challenge Red List. And this is a list of chemicals that the International Living Future Institute, ILFI, have identified as being the highest concern to avoid. Even if you might not currently be able to interpret all of the information included in these documents, asking manufacturers for this disclosure and preferring products that have transparency is really a powerful way to help change the building materials market. And HBN has some information about why this is important, as well as a template that you can use to ask manufacturers to disclose, and a guide to help you understand these documents. And I'll put this link in the chat in a moment. If you're interested in learning more about safer insulation and sealant materials, we have a report on healthier energy efficiency materials, which includes a wealth of information, such as additional details on what the insulation and sealant products are typically made of, and an expanded cost and performance table, part of which is shown here on the slide. And there also is additional information on pipe and duct insulation and sealants. And then we've also developed a shorter, more succinct document that is guidance for specifying healthier insulation and air sealing materials. And this includes the summary guidance, like I reviewed earlier, for insulation and air sealing materials. It also has those tables with the relative cost and performance information from the last slide. And in addition, includes recommendations by product category. For example, for spray applied insulation, what is preferred, as well as some sample specification language that can be used in project specs. Those resources, as well as some additional project resources, including policy recommendations and insights on drivers and adoptability of safer materials, can be found on IFA's Healthy Affordable Building Materials Project website. And HVN product guidance for insulation and sealants, as well as 9 other product categories, can be found on our home free website. Again, I'll put those links in the chat. So thank you very much for attending today, and we can open it up now for questions.
Yeah, great. Let's get to some of those questions real quick. And before we do, just real quick, for those of you listening to the recording of this on demand in the future, not right now, you can pick up your CEUs by taking the 10-question quiz and getting an 80% passing rate, whether that's on our Thinkific channel or whether that is on the USGBC education channel or whatever channel you may be watching this on. And for those of you listening live, again, reminding you to stick around for the entire hour and then check your spam over the next few days from certs at gutenbergcerts.com, and you can pick up your continuing ed that way. We got a lot of great questions coming in. I want to get to those questions. Before I do, again, a huge thanks to our board of directors, our volunteers, volunteer speakers, our executive director, Jose Reina, and our top tier sponsors, Mitsubishi Electric, April Air for humidity control, Rheem for air source heat pump water heaters, Build Equinox for smart ventilation that ventilates only as you need it. A lot of cool sponsors we have. Check them out to help you build healthier and greener. So here's a great question that came in from our member, Dennis. Thanks for chiming in. Good to see you out there, Dennis. Please, and this is a specific question, but let's make it a little more broad. Please speak to the urethane sealants, which provide longevity and long-time flexibility for doors, windows, and door installations. But let's take it a little bit bigger. Let's think about maintenance, operations, replaceability, functionality. Where does that come into your studies, considering, okay, maybe I'm going to choose the healthier product, but is it going to work as well? Is it going to break down? Do I have to replace it more often? Can you speak to that a little bit?
Yeah, that's a very good question. So in terms of the ranking of the sealants, it doesn't take into account currently the longevity of the product. There is quite a bit of variability between different specific products within the different types. Certainly a consideration. I think what I would say with respect to the longevity of the polyurethane sealants in particular is, if you're putting that inside your building, those products typically contain phthalates. So the longer they last, the longer they're in your building and emitting those chemicals into your environment. So certainly there are a lot of considerations when choosing materials, and we think that material health should be part of that conversation. Anything to add to that, Vienna?
No, Rebecca answered it perfectly.
Okay. So building code, typically speaks to energy efficiency, and if we're lucky, is starting to look at ventilation. But usually that gets tossed out by most states, unfortunately. So for anyone who doesn't know, building code may be addressed at the international or national level, but it is codified by every state. So it doesn't matter really what the international code says. It means really nothing. So with that being said, what conversations are being had to also add in health when materials being chosen? And I don't want to throw out the value of engaging with IECC. Clearly it's referenced. So, what is being done to speak directly to IECC about implementing these in the code? And then even at state level, is there anything going on? I know California is doing some great work, but can you speak to that a little bit?
Sure, I can take a start at this, and Rebecca, feel free to jump in if you have anything to add. I have to say I tend to agree with you, Brett, that the engagement at the International Code Council level can be a bit of a challenge, and that ultimately what gets adopted by states and jurisdictions can differ from that. But so that being said, I think there is what we've seen is there is certainly a desire to better integrate health into the building codes, and that, there's kind of bringing forward proposals and putting it in front of the code council and really having that conversation is important to help move the ball, to have the building codes more holistically look at buildings and their impacts on our lives beyond energy. So I think that is a good and important discussion, and definitely encourage folks to get involved in that at the code council level, and also that at your more state or local level, that really putting forward comments supporting integrating health into state and local building codes can be very effective. You mentioned California, and the Cal Green Building Code has some, good, stronger requirements on VOCs in sealants and other materials. So we are seeing some progress on state and local levels related to better and integrating health and material health. And the last thing I'll say about this is that building certifications can have an important role to play. We've really seen material health and health being addressed in a number of widely used building certifications, like USGBC's LEED, like Enterprise Green Communities for affordable housing, like the Living Building Challenge. So that's another way that folks can start to address this issue within their own practice, and to really support their local jurisdictions and states to adopt building certifications for public buildings, other buildings that might have public investment, like affordable housing.
Yeah, and I'm glad you ended on that note. You make a good point, because if those of you pursuing low-income housing tax credit projects, most states require the use of a green building program, and therefore there's either some requirements or incentives for these healthier materials. And then you've got other states or cities like Cincinnati, which is sort of leading the way on tax abatements for LEED certification again, and the higher you go, the better. So encourages you to use these. Even the state of Michigan has a way to use green certification in lieu of code, though it's kind of written weird, so it never gets used, but it is happening. So thanks for pointing that out. Did you have anything to add to that, Rebecca, on the code side?
No, I don't. I think that was a great answer. I was just going to add a link to the chat for anyone in the affordable housing realm or others who are interested in the material health criteria in Enterprise Green Communities. We do have a resource specifically for folks to support them in going after those safer material criteria. So I'll put that in the chat.
Great, thanks. And we'll try to share that resource for any of you listening live as well. So some of these studies and these reports, I've had this report on my desk now since 2018. I've been super excited to try to reach out to you all and get a session on it. And it's been a while. And I know it's a little bit dated. And you consider the fact that, well, first of all, we've had a labor shortage in building, even predating the global labor shortage. It's even worse now. And of course, now we're dealing with a material shortage. And then on the flip side, we're dealing with agencies rapidly moving to use healthier or less carbon intense materials. And as you mentioned, they kind of go hand in hand. So with that, are these kinds of things being updated? Are these reports getting updated and resent out? Because I have to imagine, things have changed. So.
Yeah, that's a great question. And things can change both quickly and slowly at the same time. But we have not updated the base report itself. I would say the vast majority of the information in there should still be accurate. But on the Home Free website, we do have an updated hazard spectrum for insulation. And we've, broken out some of the things that I showed today, like the formaldehyde-free mineral wool and the halogen-free polyiso are newer products that have kind of come out since the report was written. So we do try and keep that guidance on home free up to date as much as possible as new products are developed.
And then you had mentioned, from just sort of a criteria standpoint, the disclosures and declare. But what about, and I'm going to pick on these folks because they're big, and so I think it's okay to pick on them. But what about our friends over at Green Guard? They're certifying all sorts of stuff to make you feel really good that it's going to be at least less bad, and healthier, to be sure, a good thing. But you kind of just really spoke really more to the ones that give you the ingredients, as opposed to going to an agency that says, hey, we verified this, it's going to be healthy. I mean, can you speak to that a little bit? As is it that we want to have things that just tell us what's in our products, or is it important that agencies are actually doing the testing to make sure that the results are healthy, or both?
Yeah, I think it's a couple of different things. I think that there's this basic idea that we have a right to know what's in these materials and a right to decide what we're going to put into our buildings. Mm-hmm. So that's really the driver behind the material transparency movement. Certifications can be really powerful if they cover the breadth of the issue. So you mentioned Green Guard, which is based on the California Department of Public Health standard for VOC emissions. There are some other standards that use that same standard as the base. Mm-hmm. And they really only cover something like 35 chemicals that are volatile compounds that may be emitted from products. So while it does tell you something about the material health of a product, there's certainly a lot of things that are missing. Most of the things that we talked about today as chemicals of most concern in insulation and sealants are not covered by Green Guard or that CDPH standard. So they can provide some information in addition to, in particular, preferring product types that generally avoid those chemicals of most concern, or products that have fully disclosed their contents so you can verify.
And if I could just add to that a little bit, and I think this also speaks to the question that Brian put in the Q&A as well as this just kind of challenge of balancing all these different requirements and issues that we're thinking about. That really, one, bringing this issue into the factors that you're considering, I think is the first step, just to understand and know about it. And that even taking one step kind of up that ladder of healthier materials is a good step and makes a big difference. So even if you're not going all the way to the top, you can't use like the healthiest material you might want, it's too expensive, you're still making a difference by even reducing VOCs or going from spray foam to one of the healthier materials. That's any step that you take in that direction is a good and positive step. So I think sometimes we let the perfect be the enemy of the good enough. And that, I really want to encourage folks just to start to think about this and take the steps that they can.
Yeah, definitely. Very, very important to kind of just start wherever you're at. And then that's what we always tell folks, like, just kind of do an assessment, whether we're talking about energy efficiency or water conservation or ventilation or green in general, do an evaluation of where you're at, what materials are you using, and what can you do to do better on the next project, and then do better on the next project, rather than trying to get overwhelmed and try to make everything, immediately. Just, pick a few and then go from there. So I appreciate that. Real quick, a couple other kind of specific questions came in. I know your study, Rebecca, addressed sealants. How much did it get into these new types of sealants that you can kind of go in and really, they're pretty cool. You can just basically say, look, we want our air change rate to be passive house levels, for example, right? And in the past, we had to sort of guess. We had to kind of cross our fingers and hope we could get there. and it just kind of was what it is. But now we can walk away from a building with the air change rates that we want at passive house levels, ideally, and the duct leakage rates that we want with these new things that you can just blow right in. But I asked this question, I'm still concerned. What is the health ramifications of these sealants that are getting us to our air tightness targets? But, what are they off-gassing? What's in them? Was that part of your study, or is that something that Healthy Building Network is looking into?
Yeah, that's a good question. Those products were just sort of being developed when we were doing the research for this project originally. And we have looked into them from time to time. It certainly is a compelling idea of the performance that you may be able to achieve. Like you, it makes me nervous about this thing that you're just sort of spraying everywhere into your ducts. What does that mean for the air quality of the air that's going to be going over that material? And I think the short answer is we don't know. So this is sort of a unique one-off product that has been patented and hasn't been disclosed. So we don't know exactly what it's made of or what the ramifications may be. So we would tend to take a precautionary approach and not use that material without more information. Any of you who are using that material or interested in using that material could reach out to the manufacturer and ask them to disclose. And if people ask, then that may be something that they're willing to provide.
Awesome. Well, we are at our time, and Vienna, I know you have to get going, but I really appreciate both of you for taking some time here. Rebecca Stam, Healthy Building Network, Vienna Singla with National Resource Defense Council. Where can people go to contact you or learn more if they want to follow up?
Well, you can go to NRDC's website, and my email is on the slide there. Also, folks are welcome to add me on LinkedIn as well, and I'll put that in the chat.
Yeah, and I'll just say my email as well on the slide. We put a bunch of links in the chat for the different resources that we talked about in the Home Free website. If folks are interested in getting more involved with our work in affordable housing, please do feel free to reach out, or if you have additional questions.
Awesome. Rebecca, Vienna, thank you again so much. It was great to virtually meet you out there and to join you all. And speaking of health, let's all stay healthy. Let's get vaccinated. Let's use building science to ventilate and filter our buildings. We know it can help us in so many ways beyond just COVID-19. And we love webinars, but we want to see you all in person someday again and do more in-person events. So we got to beat this thing and get back out there and just really be healthy. It benefits us all. So take care, everyone. Have a good week. Thank you. Bye.
Thank you.
Thank you. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.